I'm going to take a second and imagine a car moving rightward with a velocity. If its acceleration is also to the right, then it would be speeding up. If it had a velocity in this direction, again, but this time what if the acceleration was here? And what I could do is I could imagine that that acceleration could be broken into components. So this part of the acceleration on this side of the triangle would be helping the car to speed up because it's working in the same direction as the velocity. But what about this component of the acceleration? It can't speed the car up because it's not working with the direction of v. And it can't slow the car down because it's not working purely opposite the direction of v. So this component of the acceleration turns the car. So in this case that I just drew, this car would be speeding up because it does have some acceleration forwards, but it would also be turning to the right because it would have some acceleration to the right. So that brings us to circular motion. What if we imagine a car on a track now? At constant speed. And another way of saying that in physics is uniform speed. So I'm going to draw the velocity always tangent to the path, but having the same length, and that's going to indicate the same speed. So because the car is always turning, the velocity is always changing. Not in size, but in direction. So if you're going to turn in a circle, you are always accelerating. In a car, you actually have 3 accelerators. The gas pedal accelerates you forwards, the brake pedal accelerates you backwards to a stop, and the steering wheel accelerates you left and right. And all 3 of them. So if I was going to indicate the direction of the acceleration at this instant, it can't point forward, that would speed it up. And it can't point backwards because that would slow it down. The acceleration is perpendicular. Same here. So whenever you're traveling in a circle at constant uniform speed, the acceleration always points to the center of the circle. So we can give it a special name. We're going to call it centripetal acceleration, and centripetal means center seeking. There is a nice shortcut that we get in this section, that the centripetal acceleration, which we can abbreviate as AC, is going to be equal to whatever the speed was squared divided by the radius of your path. And its acceleration is a vector, so it's going to be inwards. As an example, let's say that you were going around a curve on a road. And let's say that your speed was equal to 10 meters per second, which is about 22 miles per hour. And let's say that the curve that you were traveling around had a radius of 20 meters. What acceleration would you feel just by moving in a circular path? So we can, since we're moving in a circle, we can use this equation. AC is equal to v squared over r, 10 meters per second. We're going to square that, divided by r of 20 meters. So we get 100 meters squared per second squared, divided by 20 meters. So we end up with a value of 5, and then there's a meter squared in the numerator. But one of them will get canceled out by this one right here. So we'll just end up with meters per second squared. But if the question just says, what is your acceleration? It's implying the full acceleration, as in it needs a magnitude and it needs a direction. So in this case, you can just say inwards. So for your final answer, 5 meters per second squared inwards.